Hi, here we are with another episode in this series. Today we're going to talk about R squared. It's a statistic that provides a measure of how well the model is fitting the actual data. It's a number between 0 and 1. R squared equals 0.72 means that around 72% of the variance found in the target variable can be explained by the predictor. If you want to learn more about the target variable and the predictor, check out the video right here. But in a nutshell, the target variable is what you want to predict, usually shown by y. It's a dependent variable on x, and the predictor is the independent variable, or you can show it by x. What you want to use to predict is the predictor. So let's visualize the statistic. R squared will help us explain how much of the variation in y is described by the variation in x. R squared error is what percent of the prediction error in the y is eliminated when you use our model. R squared error is what percent of the prediction error in the y is eliminated when we use our model on the x variable. You can think of it as the R squared is 1 minus what is not described by our model, which in this case is a line, it's a linear model, over the total variation. So the variation that is not described by the model How can we get the total variation? Let's say we don't have the linear model. The expectation or the mean would be a good assumption to predict the values of y. So let's say the mean is a dotted line. In order to find the error from this mean, we get the distances here. We square them up and we sum them up. So let's call that the error of the line, the error of the mean, and it would be the same as getting the first data point, subtracting it from mean, square it up, and do it for all the other data point until the nth one, which is our last one. That's a total variation. Now let's say we want to find then what is not described by the model would be the error that the model is giving us. So again, back to our line, we find the distances from this data point to the line, from each data point to the line, and we sum them up. So it would be error of the line is equal the first data point minus our line is modeled by mx plus b, so it would be mx1 plus b squared, and we keep doing it for all the data points. And we square them up, sum them up. Now, R squared is 1 minus something that doesn't describe the model over total variation. It means R squared is basically what does describe the model well. So the higher the R squared, the model is a better representation of our data. Keep in mind, however, we say the higher R squared values represent smaller differences between our observed data and the fitted data, where this is the observed data, and this point, for example, would be the fitted data for that specific data point. So the higher R-squared value represents smaller differences between the observed data and the fitted data, but keep in mind that whether or not the R-squared is good depends heavily on the subject matter and the application. So you can't say R-squared of 0.72 is a good or bad R-squared. It really depends on the subject matter and the application. In the next episode, I'm going to explain the differences between R-squared and adjusted R-squared in the models that you see in Python. I can't wait to see you in the next episode. Please like, subscribe, and comment for more videos to come. I'll see you later.